Hi ladies, so Max is sick and so I'm going to just record a little video for you um, about what we're going to talk about for 10.2 today. So a lot of the things in 10.2 are going to be similar to things that we've already talked about, and so I filled out some of those things on your notes because I was anticipating that we would be doing this in class and we would have less time, so just some of that's already filled out. But it should be pretty familiar to you. So in 10.2, we're talking about comparing two means as opposed to comparing two proportions in the previous section. So just like when we compare two proportions, when we compare two means, we're going to want to choose a simple random sample of size n1 from population 1 with mean mu1 and standard deviation of sigma 1. Then we need a separate independent simple random sample of size n2 from population 2 with mean mu2 and standard deviation of sigma 2. And then when we do this, the sampling distribution of our x bar 1 minus x bar 2 will have the following properties. So shape. So we want to determine if the shape of our sampling distribution will be approximately normal, and there are three ways to do that. This is just like the three ways that we learned about in chapter 9. So again, the easiest would be if the population is approximately normal, but this has to be true for the population of both of the populations that we took samples from. The other thing, the next thing that we could check is that both of our sample sizes are greater than or equal to 30. So then by the central limit theorem, our sampling distribution would be approximately normal. And then if neither one of those two things are satisfied, then we have to do a box plot. And we have to do a box plot again of both of the sample data that we have. And you can just do it once on your calculator, and I'll show you how to do that in a second. The center of our sampling distribution, so the mean of the differences of our means would just be mu1 minus mu2. And then for the spread, as long as the 10% condition is met, then the standard deviation for x bar 1 minus x bar 2 would be the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. And I'm pretty sure that is in, let me look real quickly, I'm pretty sure that's on the topics page. On the formula sheet. So, there we go, that's just right there, okay? So that's right there. All right, so again, this is when we know our population information, which is not often going to happen. But if we do, then we would have an example. Sorry, this is, I don't know, from homework or something. Then we'd have an example like this, potato chips. So a potato chip manufactured buys potatoes from two different places, Riderwood Farms and Camberley Inc. The weights of the potatoes of Riderwood Farms are approximately normally distributed with a mean of 175 and a standard deviation of 25. So this is the population information for potatoes from Riderwood Farms. Okay, so we're saying we know this about the potatoes that come from there. For Camberley Inc., the weights are, again, approximately normally distributed with a mean of 180 grams and a standard deviation of 30 grams. So when the shipments arrive at the factory, inspectors randomly select a sample of 20 potatoes from each shipment and weigh them. So let's let x bar C minus x bar R be the difference in the sample mean weight of the two suppliers. So the population of the sampling distribution we know would be approximately normal because it mentions in the paragraph that both of the populations are approximately normal, so that takes care of that. The mean of the sampling distribution, so what that means is anytime I pull 20 potatoes of Camberley potatoes and 20 Riderwood potatoes, and I find those two means of that sample, and I subtract them, if I do that over and over and over and over and over again with all the possible samples of 20 potatoes from each, the average of all of those differences would be 5 grams. So on average, I would get a difference of 5 grams from those samples. And then the standard deviation for x bar C minus x bar R would be that formula right there. So we end up getting 8.73 grams. So again, that's when we know the population information, which is not often the case. So then we change a couple things, right? If we don't know the sigma, we don't know the population standard deviation, that's when we have to use t-distributions, just like we did in the previous chapter with our significance tests. Instead of being able to find the standard deviation of the difference of the two means, we have to use the standard error because we're going to use the standard deviation from our samples. So just the same exact formula we had above, but now instead of sigmas, we're going to use S sub x. And again, it's because we're using sample data, we call it the standard error instead of the standard deviation. And then this right here, this formula for the two sample t statistic, again, if we go to the formula sheet, this is the standardized test statistic format for all of these things we've been doing. Anytime you're finding a z-score or a z-star critical value or a t-star critical value, this is the general formula that we're using. So the statistic that we're going to be using in this case is we took a sample from one population, we took a sample from another population, we found those two means, and we subtracted them. So this is our sample statistic right here, this x bar 1 minus x bar 2, minus the parameter, so the mean of population 1 minus the mean of population 2, all over the standard deviation of the statistic, which is our standard error, so this formula right here. So again, the calculator is going to do all of this for you, but it's good to know the format of this formula so that if there's multiple choice questions that require you to know which one has been calculated properly and it shows you all the numbers input in there, you are able to figure out which one is the correct one. So before you can do anything about these differences in your means, you have to check your conditions. So just exactly like before, okay? So the only thing that's different here from when we checked conditions for means before is now we just have to do everything twice. So for random, again, we've already talked about this. Simple random sample from both populations. For independence, again, we would write that we are assuming that there's more than 10n in each population. And then we have these three things to check. Okay, so for all of them, we have to do it for both of the samples. In terms of degrees of freedom, because we're talking about t-distributions here, this is the formula for degrees of freedom. Okay, so if you remember from previous sections when we did degrees of freedom, it was just n minus 1. It was 1 less than our sample size. But now that we have two different samples and two different populations, it gets way more complicated. This is the formula. You never need to worry about this formula. You just need to know that the calculator figures it out for you and it's not n minus 1 anymore. Okay, so you'll see degrees of freedom pop up in your calculator, and this is the whole mess that it's coming from, so that's why it's not n minus 1 anymore. So when we have met the conditions and we're ready to do a confidence interval, the method that we're going to do is a two mean t interval or a two sample t interval. In our calculator, it's under stat, test, and then looks like that's 0. We'll check when we look at the calculator, but I'm pretty sure it's 0, and then it's two sample t int. And the confidence interval has the same format that it has had previously, so our point estimate plus or minus our margin of error. So our point estimate is we took two samples, we found the means of our samples, and we found the difference. So that's our point estimate, plus or minus the t-star value that our calculator has to give you times the standard error. That was that formula we've seen a couple times. And so the last thing that we need to do is, I'm just check my time real quick. The last thing we need to do, please tell me that this is recorded.